Okay, let's begin class here. So today you need to examine subsections 6 and 7 of section 4, which basically took what we learned in subsection 5 regarding these arch models, and now let's actually use R to estimate these models. The main thing to get out of this section is how to use R, how to actually then state these estimated models as well. Now, there are a number of different packages in R that actually estimate these models. We are just going to focus on the fgarch package. First of all, to simulate these kinds of data from these kinds of models, we could use the garch sim function. To estimate the models, we use garch fit. Now, an interesting thing that comes about with using this is that we need to use basically the S4 version of the S language when working with these kinds of functions. Just out of curiosity, do you learn about S4 in Stat 850? Yes or no? Okay. So, as I explained in the notes and the videos, R is based upon mainly what's called S version 3. There's been a number of other versions that have been created since S version 3, but none of them have really caught on a whole lot. S4 is probably the most popular of them, but still it's not widely used. As you can imagine, that since it's S4 versus S3, there are advantages to using S4, and I guess there is a little bit, but I don't think the advantages are enough to really warrant learning S4, and I would just always stick with S3. But the main thing that you need to get out of this is how can we work with objects that are created with a function that creates something using S4. And the main thing is that when you have a list, in order to see the components of the list, rather than using the names function, we have to use slot names. If you want to extract something from a list, rather than using the $sign to help you get at that component in the list, use the @ symbol instead. That's the main thing that you need to get out of this. Now, we can use the plot function. It's a generic function to work with stuff that's produced by garch fit. And we have a number of different diagnostic plots that we can examine with the plot function. So there's a method function that the authors have created for fgarch that allow you to do this. And then lastly, how can we forecast x of t with these kinds of models? So with that, are there any questions regarding these two subsections? Okay. So just as a reminder, you have these course evaluations to complete. There are 2 different course evaluations, and it's completely fine to say one thing on one course evaluation and then say exactly the same thing on the other course evaluation. So it's okay to say the same thing. So with respect to the standard course evaluations that are given at this university that are available on Canvas, so far we've had 7 of 12 students in our class complete these course evaluations. So that's good. But there still means there's 5 more that need to complete these evaluations. So please make sure to do that. And again, I think you have until Saturday of this week to complete it. Don't wait till Saturday, just get it done. You do need to do the week number 15 quiz/survey, which is my version of a course evaluation. Please do complete that. You at least need to answer that first question. And that is due the usual time today. Now, since we last met, I posted on the discussion board some information about grades for our course. I've uploaded all the project grades, the test grades to the grades portion of Canvas. Please make sure you look over those grades to make sure I got it right, because it can happen that sometimes I will accidentally enter it wrong. Now, with these grades, there's some additional information that Canvas automatically produces that is not actually meaningful for our class. I cannot actually remove it. So you'll see something called assignments, imported assignments in total. Just ignore those. In the end, what actually determines the grade is I have an Excel spreadsheet that I save all the results in. And I have some formulas written in the Excel spreadsheet that calculates final grades corresponding to what's on the syllabus. Now, also in Canvas for the grades, as I mentioned, I think I mentioned on the discussion board. Yes. I have what is your current grade. And it's listed under what's called the percentage grade after quiz number 14. So it's everything but the final exam and this quiz that's due today. The way that I figure this current grade out is using the information that's on the syllabus. I take your projects and quizzes overall percentage grade. So number of points possible divided by, number of points earned divided by number of points possible. I take that times 0.3. Excuse me. Then I add that to your highest test grade times 0.4. Add that to your lowest test grade times 0.1, divide by 0.8, because essentially 80% of the grades for this class have been done. And that's how I calculate your current grade right now. So just as a quick example, if you had a 92.48% for projects and quizzes, 95% is your high tests, 80% your low tests. If you do all the calculations that I just showed you above, and also you can see just our code that does it as well, then that grade's 92.18%, which would correspond to A- in our course. Do note that I do assign plus and minus grades. It's what's given on the syllabus. Now, after the final exams are graded, and I've calculated all the last, your overall grade. There we go. I will upload your final exam grade. I will upload your overall course percentage grade and your overall letter grade to Canvas. And that's where you can check that information out. I will let you know when that is done through a discussion board post. Although I think Canvas will automatically notify you too. Okay. Were there any questions about the grades that I've posted? So let's talk about the final exam. So the final exam is Thursday, May 16th, 10 a.m. to 12 p.m. in this classroom. There is a format change from what we've done before for tests. You will not use a computer for it. I often will do this on the last tests of the semester because you've shown me that you can use a computer for tests already. So just to help you out a little bit, essentially I've done the computer work for you. So what that will mean then is when it's 10 a.m. on Thursday, May 16th, I will pass out a paper copy of the tests. I will pass out a paper copy of all those equations that were available to you as well on the graded webpage. I will pass out a paper copy of our code and output that I've generated corresponding to the problems on the tests. Using that R code and output, there will be some parts of the tests where you will need to look at it and then answer a question about it. So the simplest could be simply tell me or state the estimated ARIMA model based upon what you see in the output. Okay? So at the end of the test, then you'll just hand in all that paper stuff. You will not need a calculator then, also for the test, because you aren't going to be using a computer at all. Now, there can be times on the tests where I might say, find the forecasted value for one time point into the future. Okay, well, normally, you would just get that information from R, like use the predict function. But I might say instead something like this, where I say, set up the calculation. show me how you would actually, write out the formula in terms of, like phi hat 1 plus x sub n plus, you write out the formula based upon the information that's given to you in the output, and then that's your final answer, where you don't need to do a final numerical overall answer. So it should be clear during the test when you would need to do something like that. You will not need to, though, use a calculator or do any actual formal calculations on the test. The test still remains closed book, closed note, closed video. The one big difference is that you won't have access to my R programs because you're not using the computer. Are there any questions about this format? Okay. Let's talk about the structure of the exam. It is a comprehensive final exam. In terms of the amount of material that you have not been tested over yet, about 25% of the tests is based upon the stuff after our FEMA models. When you do the tests, you still need to show your work. If you're deriving something, you need to actually show me all the steps. Don't just magically get to the last step. That gives me the final answer. Make sure if you're doing some kind of hypothesis test, set up the hypotheses. And the reason I ask you to do this again is because I can assign partial credit. The problem types, despite the small format change, are still the same as before, where I might have a data set, and normally you would go to R and write a little bit of code, get some output. I've essentially done that for you. Now that you got that output, now you need to use it to answer some questions. And then also you might have to interpret then the corresponding stuff that you get as well. You will need to derive some stuff at times on the test. So that will be, let's say, another kind of problem format. And also there will be one short answer problem set where the parts are not connected in any way, similar to what you've seen as the last problem on the test 1 and test 2. Some additional information. I mentioned this last time, but I want to emphasize it. Is that I like to go back to test 1, test 2, see the problems that sometimes students were having difficulty with. I want to make sure, though, now you do understand that material, so I will often put similar types of problems then on the final exam. There will be 2 times where you're going to need to derive something. So for example, maybe it might be you need to derive a forecast. Maybe a forecast error variance. Maybe derive a ACF or something like that. Okay, so that's the format. Any questions?
Will subsections 8 and 9 be on the
No. Sorry if that wasn't clear before, but yeah, I think we're only going up to the stuff that was for today, which was up to subsection 7. You are welcome, though, to continue and read subsections 8 and 9. Okay, so in terms of the actual material for the exam, everything that I've talked about before for a test 1 review and a test 2 review, if I were to go over that same kind of material, I would say exactly the same thing for the review. And so for that reason, I'm not going to do that here. We have recordings of me doing that. So I strongly recommend that you go back to the past recordings of test reviews to see what I had said then. But let's focus now on the stuff after the RFEMA models. So we have these regression models with ARMA errors. And so, our model would look something like this, where we have a dependent variable, a response variable y sub t. We have, let's say, beta 0 plus beta 1 times z t1, which represents the explanatory variable or independent variable at time t, and it's the first variable. And you could have additional variables as well, but let's say we just only have one, and then we would normally put, like an epsilon after that for our error term. But now with these kinds of models, we're going to put x of t, because we're going to allow for the fact that these error terms could be not independent. Dependent. That's a more concise way to say it. And the dependency, the way that we're going to account for the dependencies through these ARMA models. And so since we've always used x of t before for that, we'll just use it here now as well. And so that's what the model looks like. So, I have here, be careful with x of t, meaning that, normally we think of x as an independent variable when we have some kind of regression model. That's not the case here. Instead, it is actually an error term. And so we need to somehow choose an appropriate ARMA form for x of t. And the standard way that we do this is that we estimate a model assuming independent error terms, look at an ACF, look at a PACF of the residuals based upon what we see there. That will suggest particular kinds of models for our error term. And so then we refit the model. The way that we do that is we use the UREMA function with the xreg argument. We refit the model, and we then get the residuals again and check to make sure that we've taken into account this dependence properly. Unfortunately, there are, I guess you could say, some forecasting issues, and that is if I want to forecast one time point ahead of where my data is, well, I also need that independent variable. What is that variable in the future, or what is that value in the future? That's unknown to us. This is the future. And so you might have to make a guess about what that future value would be, then use that then to help you forecast what y sub t would be. We also had a small subsection on multiple time series where we just simply focus on 2 time series at a time. In that particular case, we're very interested in something called the CCF, which can stand for the cross-covariance function or the cross-correlation function. It helps us measure the dependence between, let's say, x of t and y sub t. With our definition of the CCF, then, we can look at joint stationarity. So this is the extension to what we saw before for stationarity, but now we want the CCF to not be dependent upon time other than through the lag difference in time. You have to be very careful in understanding equivalences corresponding to the cross-covariance function and cross-correlation function, where notice this gamma here represents that I have a cross-covariance function where I'm going to put x first, y second. I have an h lag difference in the times between the two. This is equivalent to if I put y first, x second, and have a negative h lag time period. The key is lag. The key is that x is still h time points ahead. And you can write out the expression in terms of expected values to actually see that. This was part of a quiz question that you had, I think, last week. But also, this means that some other cases we do not have equality. So make sure you understand why. Again, go back to writing out the expected value. The best way to actually estimate the cross-correlation function is use the CCF function. And then lastly, we talked about these arch models. When is this kind of a model appropriate? Well, it's appropriate when the variance changes as a function of time. In particular, in financial situations, this model can be very helpful in situations where you have what are called periodic shocks to whatever kind of financial measure you have, meaning that the variability becomes really big just over a short period of time, and then goes back to normally what it would be. So there's different ways to write out these models. One way is that I could say, well, x of t is equal to, let's say, mu plus wt. Notice this would be our normal white noise type of model with a non-zero mean. The difference, though, now is that I have that t on that sigma squared. This allows sigma squared to change as a function of time. How is it changing as a function of time? Well, here's our expression for what sigma squared t is. So we can see it's a function of some parameters that we want to estimate, these alphas, and also then these squared y values, which is just simply xt minus mu, which you can kind of think of as a residual. I could also write out the model like this, where yt is equal to sigma t times epsilon t, where this epsilon t is distributed independent with mean 0, variance 1. We have the same expression for sigma squared t here, and notice y sub t would have to have a mean of 0. So why am I presenting two different ways to write out the model? It's because this is typically the way that you will see it presented both ways. That's why. We could also have these ARMA and ARCH models together. So when we've looked at ARMA models in the past, when we had non-stationarity in the variance, we knew that was an issue. We wanted to take care of it. Here's a different way to take care of it from what we had in the past. And as I mentioned earlier, we have the FGARCH package that helps us estimate. And that's the only of the three packages I mentioned that you are responsible for. Okay, so let's review the material. Any questions? Okay, so what I want to do next, since we do have time, is what I often like to conclude classes with is some recommendations of other courses that you could take. In particular, courses that seem to be the next step of courses after this one. If you find that you really like this course, what would you do next? Also, I'll give you some other general recommendations for potential courses to take that are not necessarily related to this. Now, in our department, there are no other time series courses available in the Department of Statistics, I should say. This is not unusual. Most departments of statistics have one and only one graduate level time series analysis course. I rarely have seen like a time series analysis 2. Probably the closest course to this one that we offer in terms of the same kinds of things of interest is Stat 831 Spatial Analysis, or Spatial Statistics, excuse me. And basically you can think of as spatial statistics as being a time series like data, but now in 2 dimensions, spatial. So, I've never taken a spatial analysis course, and I have very little experience with it, but you can think of it now that maybe you have data that's measured in a longitudinal and latitudinal scale. So now you could have, let's say, data that's collected at different points in space, and you want to take into account the dependence that could occur because of how that data is collected. And so that's why it's kind of a 2-dimensional, let's say, time series type of situation. Normally, this course is offered small fall semester and odd-numbered years. I have a question mark there because the person who last taught it, unfortunately, is no longer here, so I don't know exactly when it will be offered next. But if you want to do more like time series-like courses, economics and finance are the places where, and I'm not just talking about at this university, but just in general, that's the places where I most often see advances now in time series analysis. What you've seen here in this course is that there are often many examples of where, we have like a financial type of number that we're interested in, or something that's related to economics. And that's why people who are in this area, who are advancing the area, are often in econ and are often in finance. So if you really like time series analysis, it would be helpful to take some courses in these other departments. And what you can see here for these econ courses, there are a number of them that would work. Typically, you think of this in terms of what's called the area called econometrics. Now, do note that this Econ 817 probably will be too easy for you. It's like a regression course. The reason why I bring this up is that, at least in the past, on various student committees that I've been on, we have not allowed students to use this particular course as part of their list of courses that they're using to graduate because it's too low of a level. Okay? You might be careful about Econ 917 as well. It can have some overlap with some of our other courses here in the Department of Statistics. So let me bring up, I know that there's some students in here that are not stat majors, but at least right now I'm talking to stat majors in terms of what we would allow in the Department of Statistics. Now, this Econ 920 course, this is one that I mentioned to you previously. It's taught by Mike Ricks over in the Econ department, and this will be his first time teaching it. That might be a good course to take as a follow-up to this course here. Now, in the past, so I periodically will contact Econ and say, hey, could you give me a syllabus for your courses so I could tell time series analysis students about what would be a good course to take? Now, before Mike Ricks had contacted me, I had last contacted Econ probably 2018, 2019, and to find out more about their courses and stuff. And at least the way that 920 was taught then, it seemed to be like a time series analysis 2 course. There was a little bit of overlap with what we did here. But the topics that were listed were ones that were essentially like the second half of Shumway and Silfer's book. Now, at least what Mike Ricks presented me, it looked like he's deviating from that somewhat. But I just wanted to mention it because he might not be the only person who teaches the course as well. And so this course is offered, I believe I said in the fall. Now, I contacted finance about this, and I've looked through the course catalog for finance grad level courses. I've had difficulty finding courses that would correspond to the stuff kind of like in our time series analysis course or the next step for topics. I don't know why, but I know in other universities I do see those kinds of courses, but at least here I do not. I'm not for sure why. Okay, well, what about other, let's say, non-time series analysis courses for next academic year? What could you take? Now, Stat 875 categorical data analysis is, at least right now, scheduled to be taught in the spring semester. And this would be one of the number one courses I would recommend because I'm the one who usually teaches the course. I've actually even written the book for it, where the second edition is coming out this summer. Here's, for example, what the book cover will look like. I just approved it about 2 or 3 weeks ago, where the picture collage there is meant to represent various examples that are in the book. And of course, I always try to get Husker football represented in some way, and so I was able to there as well. Now, when I teach Stat 875, I teach it in a blended learning format, or I have been teaching in a blended learning format similar to this course here. And so what are topics that are in this course? Basically, we look at regression models where the response variable is categorical in some way. And there are three different ways that you can have a categorical variable, essentially. You can have, let's say, like a binary variable, such as the success or failure of I guess I don't have a picture up anymore, the success or failure of a field goal in football. And so one of the main examples that we look at is, well, how can I use various independent variables to try to estimate the probability of success so I can figure out what factors affect the probability of success for a field goal in football. Or again, a field goal in football is either success or failure. But there's many other examples that we look at. One that I sometimes look at is a really weird experiment that was done where the researchers were interested in if drinking beer makes you more or less attracted to mosquitoes. And so they would actually put a person who had just drank some beer in a room, and they had like some tubes that were somehow connected to the person's arm. And they would put some mosquitoes at one end of the tube, and they let the mosquitoes go, and they would see if would the mosquitoes go towards that person's arm. Now, the mosquitoes couldn't actually touch the arm, but they could smell, let's say, the scent that's given off from the person. And so essentially success or failure, again, a binary outcome. Does a mosquito go to that person's arm or not? But you can also have multi-category responses where, you could have, let's say, a response variable has 3 categories, 4 categories, and so on. So an example that I like to talk about is this was an experiment that was done about 5 years ago here on campus at the City Campus Rec, where these researchers were interested in determining what type of snack, post-workout snack, would someone choose? A brownie, an apple, or nothing? But what they were very interested in is this. They would offer this snack to a person after the workout, when they would be given the snack. Or they would say, hey, before you work out, if you do something for me, I will give you the snack after you're done. And so what they were interested in determining was, after you're working out, maybe your ability to say no to unhealthy snacks might be less because you're tired. And so we could use some kind of regression models to help make that judgment. And also you can have a count variable like 1, 2, 3, 4, 5, and so on. An example I like to often talk about is the number of people on the Star Trek TV show, the number that die. Does it really matter what kind of uniform you have? If you have a red shirt for your uniform, a yellow, or a blue. And so we can use statistics regression models to figure that out. Now, for those of you who've taken SET 822, you're probably thinking, okay, I think I see some connections here with that. Logistic regression, Poisson regression. And yes, there is some connections. But in 822, it's more geared towards experimental design and theory, where we focus more on the applications and properly interpreting the outcomes from the models. This is a mixed major course, so very often I will have half the students be non-stat majors and the other half be stat majors. As you can see here, I've had 20 different majors over the last 10 years. For stat majors who are interested in going to medical-related statistics positions after you graduate, which is probably I would say the biggest area that statisticians go into, having a categorical data analysis course can be very, very, very useful, because very often in medical-related situations, you're dealing with a categorical outcome. Does a person live? Do they die? Are they cured of disease, or are they not cured? And so on. And so you'll see categorical used throughout medicine-related applications. You can take a look at my course website that's available on my through chrismiller.com if you want to know more about the course. Now, normally this course would be offered in spring. I am not for sure if it will be. The reason being, and some of you already know this, is that I will be on sabbatical next year. So I will not actually be generally speaking, on campus next year. About every 7 years, universities give faculty an option of, do you want to take a sabbatical so you can focus on something that normally you wouldn't have time to do, or do something else. I'll just say that. And so on my sabbatical that I'm going to be taking next year, I will be actually focusing on an NIH grant that I am the principal investigator for. I will be spending most of my time doing research for that. I have a number of other universities that are helping me on this research. I'll be visiting them. I also will be, let's say, doing more, going to more conferences than I would normally, because now I don't have to worry about losing teaching time. And so that's what I will be doing on my sabbatical. I will periodically be on campus, but most of the time I will not be next academic year. So I will give you, so this is the third time I've taken a sabbatical. The previous 2 times the course was not taught. It was just simply we moved it to the next year. If you're interested in categorical data analysis, you want to take a course like this next year, I'm going to give you another option shortly. Okay, so what other courses could you take? Well, in the fall, there's going to be non-parametric statistics. This is a good topic in terms of, you've seen that we often have particular probability distribution assumptions behind the stuff that we do in statistics. What happens if those assumptions don't work out? That's what this course talks about. So the very one of the more classic topics that it would talk about is, if we had a t-test where you would want to test, is mu1 equal to mu2? Well, you do have an underlying normal distribution assumption with that. If it doesn't work out, what could you do? Well, there are other statistical methods that could be used, such as a Wilcoxon rank sum test that can be used, where essentially you replace your data with ranks. Now, the prerequisite for the course is Stat 801. So all stat majors would, even though you're not taking Stat 801, you will be able to take the course. Non-stat majors should be able to take the course. I am not 100% sure if this course will be taught with this prerequisite or a higher prerequisite. And so make sure you talk to the instructor about that. A course for non-stat majors that they could take is Introduction to Mixed Model Analysis. This is not meant for stat majors at all because there's an overlap with Stat 821, maybe a little bit 822 as well. And basically, it looks at, how can we use both fixed effect terms and random effect terms in our models. In spring, there's supposed to be some kind of statistics genetics course that's going to be taught. The exact course I don't think has been decided upon yet. We actually have, I think, 3 stat genetics courses on the books in terms of the course catalog. This came about through a professor who is now retired. He focused on that area. He developed those courses, and we basically like to take those courses and combine them into one. And so I think some kind of revision will be done in terms of exactly the topics that are taught. A very good course to take is Applied Bayesian Analysis, which would be offered next spring. This is meant for mixed majors, meaning both stat and non-stat majors should be able to take it, but do note that it does have a higher prerequisite. It's basically a similar prerequisite to what we have here. You do need to have some math stat to fully appreciate Bayesian analysis. And this corresponds to a little bit what I was talking about last week, I think it was. And then lastly, for courses here at our university, Stat 902, Advanced Experimental Design. I think not stat and non-stat majors can take it. This is another course that will be really good for those of you who are interested in medical-related statistics jobs after graduation. The reason being is because so often experimental design comes into play in understanding the results of a clinical trial or designing exactly the statistical aspects of a clinical trial. And so that's why having an advanced experimental design course can be very useful. Okay. Now, students at any University of Nebraska campus can take courses at another University of Nebraska campus quite easily. There is just a little bit of you have to fill out a little form online to do that. And the reason why that's especially important for those who are interested in taking statistics courses is that there is a Department of Biostatistics at the University of Nebraska Medical Center. Biostatistics is essentially just statistics, but the various applications they talk about are biological. That's it. I think to some respect, the statistics discipline is missing something in terms of we should put all this in one department. Part of the problem is that these biostatistics departments often exist in colleges of medicine rather than most stat departments are like in a college of arts and sciences and stuff like that. And so because of that, there's various issues in terms of 9-month versus 12-month positions. Pay for biostatisticians, unfortunately, is much higher than it is for a statistician. And so there are issues there. But, UNMC's Department of Biostatistics, they have at least 3, maybe 4 of our PhD graduates working in their department. Just to give you an idea of, it's essentially the same thing as statistics. Many departments of statistics, or I think all departments of statistics that have a PhD program, they will have some faculty that focus on biostatistics as their research area. In fact, I'm kind of one of those. So there are a number of good courses in the Department of Biostatistics in the College of Public Health at UNMC. In particular, one that I often recommend to students is their survival data analysis course. I got my PhD in statistics. My department had a survival course that I took, and this was actually one of my most favorite courses that I ever took. It really helped me understand what a likelihood function represents. For those of you who do not know what survival data analysis basically means, or the kind of data that you typically have with it, is you can think of it this way. Suppose, again, you're doing some kind of clinical trial where you're measuring how many months people live, essentially, after they're given some kind of treatment. And so maybe 3 months, 4 months, but then someone lives 5 months and then drops out of the study. Well, you don't want to throw that observation out. How can you account for it still? And so this is an example of what's called censored data, where I have information that this person survived at least 5 months. I'm just not for sure how much longer. So typically we represent this as 5+ in a data set. And so you need to be able to then construct, let's say, a likelihood function that takes into account these full observations and also these partial observations. And that's what you talk about in a survival data analysis course. Now, this course is offered every fall, and it always says it's online, or that you can take it as an online version. There's also an in-person version. One of my PhD students looked further into this last fall because he wanted to take it. And at least the instructor that was teaching it last fall basically said, I recommend that you take it in person. Don't do it online. And so I mention that because even though it says it's online, maybe it's not set up very well to be online. Another really good course. Let's say you don't have time to take the Bayesian course next spring that the Department of Statistics is offering. Also, maybe you want more theory behind the Bayesian methods. Well, there is a 900 level Bayesian theory and methods course that's going to be offered next fall. I have not talked to the instructor at all about that course, but at least from what I see from the course description, it looks like it would be a really good course to take. An additional advantage for stat majors who are PhD students, you're often looking for 900 level electives. And unfortunately, our department, at least recently, has not been offering a whole lot of them. You need to have 2 900 level electives to graduate with your PhD. This potentially could be that. You would need to talk to your committee to see if they would allow it. I know if it was me, I would allow this, even though it wasn't in the stat department, because it's a stat course, essentially just offered from another school. So that's offered in the fall. Now you might be wondering, well, geez, that's, taking courses at UNMC is going to be a real hassle. Well, it's going to be a little bit of a hassle, yes. But because they're in a medical school, they don't normally have like a Monday, Wednesday, Friday kind of course, or even a Tuesday, Thursday. These 2 courses I just mentioned are offered just 1 day a week. So, if you want, you can drive up there for the course 1 day a week and then drive back. It's about a 55-minute drive. At least I've encouraged my PhD students to consider taking these courses in person next fall. And, if there's a sufficient number of students who want to do that, perhaps one can carpool to drive up there to take the course. But before you sign up for a course, talk to the instructor. Ask he or she how they're going to teach the course. Verify that you've got the correct prerequisites. I think for all the stat majors here, you would. But it's good to talk to the instructor first. In the spring, every spring, they also have a categorical data analysis course. So, fortunately, since I won't be here, I won't be offering it. I don't know if the department will be offering it, but if you wanted to make sure that you got this course next spring, this is an option. Also, if you were not able to take, let's say, Stat 885 this semester, and you really want to take it, but you weren't able to, they have essentially an equivalent course that will be offered in the spring as well. So you could take the course there. Any questions about these potential courses? I know this is a little bit off topic for our course, but I think it's just a good thing to end a semester with so that you know what's next. Where could you go next in terms of courses and stuff? Okay, well, then I guess talking about, what's next in our course then? So I'll be available for questions after class like usual. Make sure you don't forget about that quiz/survey that's due at 8 p.m. I will be here in our classroom next Thursday for office hours and the regular class period. Please feel free to stop by. I have no other scheduled office hours, at least during finals week. I don't have regular scheduled office hours because schedules are a little bit different. But please feel free, if you want to talk to me, just schedule an appointment. I'd be happy to meet with you. And of course, post questions to the discussion board. Final exam is Thursday, May 16th at 10 a.m. So getting back to what we talked about last time, in terms of the amount of class time for, let's say, a regular versus a blended learning format, we needed to meet here for 50.3 minutes today to reach 37.5 hours in total. And we're at about 51 minutes right now. So interesting how that all works out. Thank you very much for taking this course. I hope that you felt that you've gotten something out of this course. Time series data is one of these unique types of data that sometimes, well, very often you're not going to see it in any other kind of course. It's good to have a general sense for what time series data represent, how to handle it. It's kind of like what I mentioned about that survival data, where you have sensor data. It's good to have a general sense that what that data is, how to handle it. And so a course like time series analysis gives you more breadth in your education here. Okay, so I think we are done. Good luck with your studying, and I'll see you in about, 9 days.